So now we're recording. Okay, so today we're going to be going over, oh, sorry. This lecture is being recorded. You may want to turn off your webcam if you do not wish to appear in the recording. And also keep in mind, if you ask any audible questions, that's going to appear in the recording as well. So today we're going to talk about arrays. And what are arrays? Well, so surely you've done math. So I'm always going to try to make like analogies to mathematics because it's very similar, the stuff we do in math and the stuff we do in computer science. So we have numbers like scalars, like integers, rationals, but we also have ways of like collecting these type of numbers into groups. And one of the first groups that you probably learned about was a set. So we can collect the numbers 1, 2, 3 into a set and call that A. That's one way we can collect numbers. We have vectors in math. So this is a vector X with components 1, 2, 3. I'm sure you've seen vectors. You guys have seen arrays by now, I hope. Something like this. Has any of you ever seen something like this? No? Okay, well, suffice to say, like we can put numbers in a grid and that's called an array. And sorry, not only is this called an array, this is called a matrix in mathematics. Yeah, it's a matrix. An array, a matrix, I think somehow they're synonymous. And we can also have sequences. So here's the sequence of numbers 1, 1, 2, 3, 5, 8. Does anyone recognize the sequence of numbers? 1, 1, 2, 3, 5, 8. Fibonacci sequence, yes. So every number in this sequence is the sum of the two numbers that came before it. So 2 is 1 plus 1, 3 is 2 plus 1, 5 is 3 plus 2, and so on. So just keep that in your mind because we're going to be working with the Fibonacci sequence in a bit. Okay, so every object from the previous slide, sets, arrays, vectors, matrices, sequences, there is a data type for that in Python. We're going to focus on one of them only, and that is going to be the one-dimensional type of array structure. Now, this is something that we have to call in from a library. The natural way of doing this in Python is with a list, but because you guys will be doing scientific computation, in the future, it'll be important that you're using arrays because there's some efficiency advantages for using them. And that's all we'll say. So I'm going to train you to use arrays because that's going to help you in your future. And all an array is, it's just a sequence of data. That's it. It's a way for us. So up till now, all you've been able to do sort of is say, I have the name count, and count is 1. Right? You've been able to have one name and one value associated with that name. All we want to be able to do now is have one name and like a myriad of values, lots of values, a collection of values associated with one name. And that's precisely what this array data type is going to do. Now, it's a good idea when you're choosing a name for a collection that you pluralize it. So instead of saying X is a list, we usually say sort of X is a list or an array, just to sort of, it's a nice little notational signal to say, oh, this thing's actually collecting a bunch of stuff, right? That's why I say pluralize it. Oh, and please do stop me if I ever say something you don't understand, or if something's very unclear. I sort of account for the fact that there are questions being asked when I try to time out these slides. So if you don't ask questions, I'll end up finishing short. So here we have this import that you should put at the top of every one of your Jupyter pages. This is basically an instruction to Python to say, there's some extra stuff from Pylab that I'm going to need. And this asterisk just says, take everything from Pylab out. So you don't really have to understand that instruction, but if you want to, this means from the Pylab library, import everything. And one of the things that we're importing in that everything is this array sort of function or constructor. So how do we group together 5 numbers? Well, like this. I say, here I have X's. This is a name, and this name is going to be set to an array, a collection of objects. And the collection is going to be, I don't know, 0, 10, 20, 30, 40. So the things that we have to notice here is that inside the list, inside the array sort of function, you have to give it a list. And this list has to be bracketed by squares. So that's all you have to remember, right? Just make sure when you're defining a collection, you put it in squares and then you put array over it. Any questions so far, right? This is just me showing you what to tell Python in order to have it collect a bunch of values under a single name. Okay, so that shouldn't be too hard. If I print x's, you will see that it'll print out all of the numbers, 0, 10, 20, 30, 40. That shouldn't be too surprising. There are some functions that are quite useful for reasons we'll see once we start plotting. But if you say zeros and 13, this is just going to give you an array pre-filled with 13 zeros. And just take notice of this point here. The zeros that it put in there were float zeros, not integer zeros. There's also a function called ones, which given a number will return you an array just full of ones. And this is going to be useful if you ever want to like set up a collection and you know its size ahead of time. So suppose you want to collect like 15 objects, but you don't know what they are yet. You can always say, okay, Python, give me an array of length 15 and just for now, just stick zeros in there and I'll go ahead and replace them later. So that's when you'd be using these two functions. Any questions so far? Like it's pretty critical that you stop me if you don't understand something so I can explain it, right? Because if you don't, then the whole thing's not going to make any sense. But everyone okay with what I've highlighted here at line 3, right? You can give a name and you can collect objects. Oh, great. I see. Yeah, those reactions are a great way. Thumbs up, thumbs up. Okay, so again, just stop me if anything's a problem. Okay, so again, going back to math. So we're now representing these arrays or vectors in Python. So remember, a vector has subscripts, right? This is how we would do it in math. So we'd say, okay, if I have this vector x and it collects the numbers 1, 2, and 3, then x naught is 1, x1 is 2, and x2 is 3, right? We have indexes, exponents, and subscripts in mathematics that do this. We can also define patterns, right? So remember that Fibonacci sequence, which I said is a sequence of numbers where every next number is the sum of the previous two numbers. We can write it like this, right? So here's xk. It's equal to the sum of the two previous things in the sequence where the first two numbers are 1. So the only thing that you have to be aware of is that, so there are two ways to count, right? 1, 2, 3, 4, 5, or 0, 1, 2, 3, 4. So in computer science, you start counting from 0. All right, so please keep that in your mind. That's going to be quite important. So again, 0, 1, 2, 3, 4, not 1, 2, 3, 4, 5. So in Python, in order to access individual elements from a list, we don't use subscripts, right? For one, how would we even type that? There's no sort of subscript operator on your keyboard. We're going to use square brackets instead. So here's this array, which collects 0, 10, 20, 30, just 4 numbers. So what do you think will happen if I ask for it to print x is at 0, right? So this is basically like saying x is sub-0. Great, yeah, Dante says it's 0. What about x is at 1? 10. X is at 2? Obviously 20. X is at 3, obviously 30. But here's now the question. What happens if I ask for x is at 4? 30. Well, remember, we're counting from 0, right? So this is the 0th position, 1st position, 2nd position, 3rd position, 4th position doesn't seem to exist. So this is going to give you an error. And in particular, it's going to give you an index error. And this is something you're going to see quite a bit. Even seasoned coders will throw index errors, right? So now that you have a name that you can ask for values out of, you have to be careful to never ask for an index that doesn't exist. Right? Python will crash out. It'll error, which basically stops the show. Okay, so what do we have so far? We have a way of telling Python to collect values together in a list. We have a way of accessing individual members of that list, right? And that's more or less all you need to know about arrays. Of course, that's not where I'm going to leave you. We're going to do a bunch of exercises to try to solidify this understanding, but like, how are we so far, right? Because I was told that this is something that really confuses people in this class. Good, yeah. So I've also been told somehow that we're not covering, you're barely covering anything, to be honest with you. We're trying to keep things to a minimal. You don't need to learn error handling because you won't be writing software. The purpose of this class is to teach you how to do sort of data analysis. So we have a very directed objective here, right? We just need to learn how to read data, iterate over that data, and plot. And so we'll learn how to do plotting in a couple of weeks. Yeah, no, all good. I came from, oh, well, if you came from computer science, this is all stuff that's been repeated. So no, we won't be doing error handling. But that said, you need to be able to avoid errors in your code. So in some sense, that's a type of handling. Anyways, as I was saying, I was been told that sort of the Python module of this course is the thing that most people are avoiding. And we're going to be back in the classroom next week. So please come and bring your questions, because we are soon going to have no lectures, but the time is going to be spent sort of getting personalized help from me, right? So in order to make that time like productive, you have to sort of come with questions, right? I'm not going to be doing any instruction. We'll just work together and try things out and experiment. And I'm going to try to individually unstick anyone who seems to be stuck. Okay. There's some cool things about Python, as we talked about in the first class, right? This is sort of a very high level language, and a high level language have a lot of nice little tricks and shortcuts that you can use. So not only can we index from the front, 0, 1, 2, 3, 4. Suppose we want like the last element. Suppose we want to like go backwards down the list. We can actually do that too. So here's that array that collects 4 integers together. And I actually can say print x is at -1. What do you reckon that will print? $30. Yeah. So it's going to print 30. So from that, we can surmise this is the -1 index. This is the -2 index. This is the -3 index. This is -4 index. Okay, but what happens if I ask for -5? Yeah, index error, right? The -5th position doesn't exist. -4 is still 30. -4. Oh, -4 is not 30. -4 is 0. That's a typo. Thank you for pointing that out, Annika. I will correct that before updating it. Yeah, I wrote these last night, so there may be errors. So line 9, 30 should be 0. So yep, just forget about that. That's going to be 0. Okay, so the only way to sort of gain competency at programming in general, but in particular arrays, is just to practice it. So let's write a while loop that prints every member of an array. There's nothing more simple than we can do with that. But let's make it a little more interesting. Let's say we'll print the value and we'll print what index it's at, and we'll do both indexes, the positive index and the negative index. At the moment, can we do this problem? Do you have enough to do this problem? So remind me what while loops are going to count, increment, but what's one thing a while loop has to do? Stop. How are we going to stop? On what condition do we stop? We can't stop on an error, right? Because errors just end the program. There's nothing you can do. That's an unrecoverable point. Right? So when should I stop looping through the loop? No, when it goes over a boundary is too late. End game. Yeah, when a condition is false, but what condition? What one piece of information do you need to know? If I say, look at every member of this list, right? What do you need to know about that list? Length, right? So all of you should be yelling, this question at the moment is impossible, right? You need to tell me what the length of the list is before I can loop over it, because I need to know when to stop. And I would say, you know what? That's a good point. So here's how you take the length of a list. It's LEN, right? Short form for length. So if you have an array, 1, 2, 3, 4, 5, 6 members of this list that count from 0 to 5. So the length of x's is going to be 6. What is x's at length of x's, right? If I'm asking to pull out the value that corresponds to the index at length of x's, what is this going to do? Felix says error. Any other guesses? Michelle says 5. Dante says 5. Okay, so let's walk through this. So what is the length of this list? It's 6. right? So where is the 6th position in this list? Here's the 0th position, 1st position, 2nd position, 3rd position, 4th position, 5th position. Oh crap, 6th position is actually outside of this list. It doesn't exist. So this is an error. How do I access the last element of the list? There's 2 ways. Yeah, actually -1 would be the best way. How can I do it with length? What do I have to adjust out here? Yeah, I have to decrement by 1, right? So this is important, right? You will screw this up, right? So I'm just going to repeat it again. A list of length 6 has positions 0 through 5. Therefore, the last position of an array is at length of that array -1. Or alternatively, you can use the negative positions. Okay, so let's return to the task at hand. I want to do something that I want to write a while loop that prints every element of the array. Okay, so I'm just in here. This is very much like your Jupyter notebook. It just looks a little bit different, but exact same code will work in the exact same way. So from Pylab, import everything. That's the first thing I want to do. Let's create an array called x's. Let's give it 0, 1, 2, 3. Let's make it more interesting. 0, 17. Let's count by primes. 2, 3, 5, 7, 11, 13, 17, 20. Oh, that's not a prime. 23. Okay, what's the length of x's? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So let's just call this, well, we don't have to call it anything. So we have to go over this array. So let's write a while loop. It's going to have some condition. And what do I want to do? Well, I want to do some type of count. So here's my count. That's going to start from 0. While the count, and I'll put question mark, length and x's, we'll return to this. What do I want to do? Well, I want to print something. And the things that I want to print, well, I'll show you, I'll do it in 2 ways. So here's one way we can print. I'm not really supposed to show you this, but the other way is so ugly that it actually hurts my soul. I want to do something like this. I want to say x's at this index is equal to this value, which also is equal to x's at that one. So I want to I want to print something that's going to say this. X's at 0 is equal to 2, which is equal to x's at minus 1, 2, 3, 4, 5, 6, 7, 8. Does everyone understand the objective, right? I want to get that while loop to print this, essentially. -8, -7, -6. Does anyone have any questions about this? Which I find kind of odd. So this is k. This is x's of k. And then something will have to go here too. But the way that you're normally used to doing this, so I'll do it the way that we've taught you to do it. It's just kind of messy. So it's x's at bracket, then some value, then close bracket equal to another value equal to x's at another value, close bracket. And those values are going to be k, x is at k, and x is at something that we don't know yet. What does the question mark in line 6 mean? It means we're going to return to it. Right? You're going to tell me what goes there. So here's the normal way of doing that print. I'm just going to leave it there. It's just very messy. So at line 6, what should this be? So I'm counting, right? So let's if count starts at 0. So this is going to be either less than or equal to or less than. That's basically what I want to figure out. So let's leave it at less than or equal to. So 0 is less than or equal to the length of x's. So this is going to go in and print x's at 0 is equal to 2. But what's the negative index? How do I get the negative index? This is length, right? This is length 1, 2, 3, 4, 5, 6, 7, 8. Use k instead of count. Oh, sorry about that. Thank you. Right? How do I calculate the negative index? Okay, we'll leave this out for the time being. I'm just going to put, you know, a value that doesn't make any sense. Or yeah, I'll just put an X for the time being. And we'll return to that. So I'll just show you what this does. So you're going to see the output down here on the bottom. Just give me one moment. Okay. Whoops. What's happening? What is happening and how can I fix it? Sure looks like an infinite loop. What did I fail to do? Increment count. So let's go ahead and increment count. But where should I increment count? Before or after I do this? Should it go at line 7 or should it go at line 9? Felix says after. Why? Well, consider what's the first thing that we want to check. The first thing we want to check is going to be at index 0, right? So I can't increment count here because then by the time I hit line 8, count's going to be 1. And I definitely want to do something with count 0. So that's why it comes after. So count is equal to count plus 1. Let's try running this again. Okay, so now what happens? So it's saying X is at 0 is 2, X is at 1 is 3. Great, great, great. But what happened here? What's this? And how do I fix it? Why did I walk out of bounds on this list? You have to be more precise in how you say that, Ashley. If I did this, right, 8 is in the array. What you mean to say is that this array doesn't have a position 8. Yeah, so I don't want to take count all the way to the length of the list because we know that that's out of bounds. I either want to take count to 1 less than, or I can make this a strict, right? So you have to be super careful with these edges. Okay, a lot of the errors that you're going to get are going to be walking out of bounds by 1, right? So you have to be very, very careful. Again, even seasoned programmers screw this type of stuff up. Okay, so let's run this again. Whoops. Great. So now it seems to be working more or less, but let's fix this now, right? So I want the right-hand side here. I want all of these to actually give me the negative index. So how do I get the negative index, right? So I'm just going to prove to you if instead of here, I put count and I run this, right? Okay. So 0, 1, 2, 3, 4, 5, but I don't want, okay. So those are the positive indexes. How do I modify this value so that I get the negative indexes instead? Remember, we're walking from the back, right? So how do I get it? Count minus length of X. Okay, let's try that. That seems to be correct. Count minus length of X. So good job. Sometimes it's best just to type it in and see if it works, right? But is there any questions? Because I'm very surprised by your lack of questions. It concerns me. This is a new data type. There should be plenty of questions. Like, I can't really effectively teach this class unless I'm made aware of what the mistakes are. Okay, so again, like you don't have to use the formatter. We could have done this instead. I just think that this is quite ugly and error prone. So let's see if this worked. Whoops, I used K again, count. I have more Ks. Count. Okay, so that works basically the same way, right? This is the way that you have been using strings. It's not my favorite because like this is very hard to read in my opinion. So we have something called the string formatter exactly for this reason. So it basically says, if we look at the inside of this print, this is what the strings are going to look like, but you're going to put something inside those curly braces. And what are the things that go in these curly braces? Well, in order, this will go to the first thing, the second thing will go to the second one, and the third one will go to the third. Right? So you don't have to know this. In fact, I'm not even supposed to show it to you, but it just hurts my soul to write it like this when I know I can write it like this. This is sort of more this way of printing it gets out of hand when you need to sort of print more than one thing. But again, it's not something you need to know, but it may simplify your code. So I'll just go over it again. You just write a string here, use this dot, you can say format, and then it's just going to go through here. It's going to look for these curly braces, and the first one it finds, it's going to put the first thing there. The second thing it finds, it's going to put the second thing there. And the third thing it finds, right, it's going to put the third thing there. And I can show you when I run it. You find this more intuitive, or this one more intuitive. Right. You see if I like put some extra stuff in here. Hello. It will be there as well. Can you explain increment count again? This? What would you like explained? So like we need some way of walking through the list, right? And in order to access members of a list or an array, we have to do it by index. Okay, so what are the indexes of the array? Well, what I'm saying is that their count. Okay? So this while loop has 0, then 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, right? So count is just a name which we're using to sort of just count by 1. That's it. And we do this quite often, right? You've probably seen lots of loops which do something like this. And in particular, for when you're using arrays, you're going to be doing this quite a bit. I guess suppose, like, let's write another function. Suppose we wanted to add up all the numbers in this array. How can we do that? Like one way is you can type in sum, but let's pretend that function doesn't exist. Right. So here's another question. Right. Write code to sum the numbers in X's. How can we do that? Well, Shannon, you're not the only one like it. So it matters, right? So if I print here, so print, so this is before we have count as this. And after we have count as something else. So if I print this, okay. So before this 11, count is 1, and after count is 2. It's not confusing if you know Python is just going line by line. Python can only ever go down, right? It can't skip stuff. So it goes here, it says count is 0. Is 0 less than the length of X is? Sure is. Then print count. So at this point it's 0. Then increment count. At this point it's 1. Now print it again. Count is 1. So it like there is no standard, like to say I'm confused if I put it before or after the print. That's contextual. It depends what you want to do with it. So again, had I done this, X is at count, we would have hit everything. If I do this, okay, will this work if I run it? That's going to go through this array and set everything to 0. Will this work? Let's go through it and find out, right? We'll do it in our heads, right? So the length of this is 3, 6, 8. Count starts at 0. Is count less than 8? Yep. Count becomes 1. Count of 1 is 0? Sure. But what has already happened? Remember, if my objective is to set every single element of this array to 0, and I do it like this, what has happened? Well, there's two mistakes in here. Can anyone isolate either of the mistakes? Well, so what does that mean though, right? Count is 1 by the time we do this the first time. So Luke has it. We've never done anything to the 0th index, right? So this means we've skipped 1, right? This will be a 2, right? So in this case, we needed to do this, right? So look at the 0 thing first, then increment. Okay, what's another problem with this? Like we've missed the 0 index, and we're also going to do what? We're going to step out of bounds, right? Because this count is eventually going to get to 8, right? Because 7 is less than 8. Then count is going to be incremented to 8, and x is at 8 is out of bounds. Right? So this was wrong in 2 ways. So to correct it, we have to do this. And that will work, right? Because count will become 8, and then it will fail at that condition. So let's just take a look here. Oh, I didn't do anything. Yeah, that's good. That says no failures. Okay, so back to the sum question. Write code to sum the numbers in X. So we're going to need 2 names here, like one for keeping track at which box we're looking at. That's going to be the, okay, let's change that from count. Maybe a better word is index. Okay, we're going to start at the first index. And then what are we going to do? So we also need a accumulator value. Remember these accumulators? I want to accumulate some type of sum. So I'm going to start the accumulation at 0. So you tell me, what do I put in here? What goes a line 11 and 12? I'm trying to sum up all the numbers in the array. Like how, don't even think about it as a Python program. If I gave you a list of numbers, how would you add them up? Like, what would you do? Like, I think you may keep a running total. You'll add the first 2 numbers and get the answer, then add the next to it, add the next, right? That's how you would do it in real life. How do we explain this to the computer? We do the exact same thing, right? So I'm saying, okay, like, look at the number. That's going to be the thing at X is at index, right? Oh, also make sure that we move the index by 1. So the next time this loop runs, we're actually looking at the next thing. Oh, and actually what I want to do with this is just add this to the accumulator. Is this going to work? I'll just remove some of the numbers here and we'll trace it. We'll do it by hand. So X is an array with 2, 3, 5. What's the length of X's? 3. Okay. What's X's first index? At what position is the 2 in this index? 0. Okay. What is the last indexable position? 2. Okay. So bare minimum, we need something that goes 0, 1, 2. And that's what this index is going to do. It's going to go 0, 1, 2. Great. Now we just need to accumulate the sum. So while 0 is less than 3, accumulator becomes 0 plus whatever we find at X is at 0. That's going to be a 2. So the accumulator becomes a 2. We increase. We now say, okay, now look at the next box, please. Is this index inside the array? Are we still in bounds? Yes. Okay, then take the thing there and add it to the accumulator. Great. Okay, now move again. Are we still in bounds? Yes. Okay, then add the thing to the accumulator and increase that by 1. Are we out of bounds? Yeah. Okay, then don't try to index into the list because that will throw an error. So let's see what happens here. I should probably do something like print the accumulation. 10, is that right? 5, 3, 2, 10. Great. We can also just like sort of keep adding numbers. 7, 11, 17, 23. How come there are 3 space. Oh, it's because I just want to make these equal signs aligned. It doesn't matter. Right? Somehow, I don't know. I think that looks nicer, but sure, I can just remove them. So any questions we're going to, because this is like a deeply typical design pattern for walking a list. If you can't understand this, you're going to be in some trouble. So please ask me tons of questions, right? Because so again, we just need a way of like saying this one, then this one, then this one, then this one. That's what the index incrementer is going to do. It's just going to increment. It's going to go from 0, 1, 2, 3, 4, 5, 6, right? And then this is going to be the exit condition, right? So we just sort of say, move the index. Is this index in bounds? Yes. Okay. Then access the list element and then move the index. Is it inbound? Yes. Do something, right? How can we change this to multiply all the numbers together rather than add them? Well, like accumulator is something that we do all the time, right? Accumulate a value, accumulate something. I can't call this sum. I think sum is a reserved word. Yeah. Because like you can say in Python, sum 1, 2, 3, and it will do that, right? So we've actually just done something that already exists. So I can't use sum. It just won't let me. It won't let you name anything sum. Oh my Lord. Okay, it will, but don't do that. That's just bad form, right? Don't use names that are actually names of functions that do something else. So that's why if you don't want to use the word accumulator, I sometimes use the word answer because like you're always trying to compute something. So I'm like, okay, the thing that I'm trying to compute is the answer. So I can just do something like this. Right? The names of things like don't really have any bearing on if your code is correct or not. Like the naming stuff is stylistic, essentially. Like I could have called this I and A and K, right? But then the code becomes a lot less readable. Okay, so returning to my question though about let's modify the code to multiply the numbers instead, right? So we just change this to a 1, right? Because we want to accumulate on 1 because anything multiplied by 0 is going to be 0. And then I simply just have to do this, right? And this instead should just tell me the product of those numbers. Ooh, 903,210. So is there any questions regarding this? Because again, this is a very standard, most typical way of like walking the elements of a list. And please like ask as many questions as you want. I'm here. Like sometimes the best conversations start by people asking good questions. Okay, let's move on. I think I have some more stuff we can practice in any case. So there's the answer to that question that we talked about. So you don't have to go chase me down for the listing. And there's the thing with the formatting. Ava may be a little bit irritated with me for showing you this, but again, I just think that this is very ugly and this is a lot more clear. Mutating arrays. So this may be a strange new word, but some of you may be biologists. You may know the word mutation. You may identify the word mutation means to change. And it is the case that we're allowed to change the elements of a list. So I can say, here's an array. I can say, take the thing at 0 and put in 3.14159, put in pi. Go to the -3rd position. So that's -1, -2, -3, and put in 3.14159. Okay. I'm going to print this and it's not going to look the way that we anticipate it's going to look. And then we're going to discuss why. Okay. I'm anticipating that it's going to put 3.14159 in to replace that with 2 and to replace -1, -2, -3, to replace the 7 with pi. But instead it does this. Does anyone know what happened? Well, it's not even rounding. Well, yeah, I know that like what happened was a truncation, but why did it truncate? Why didn't it just put 3.14159 in the list? Okay, So there is a nuance here that is important. You see this array? You see the numbers that I originally put into it? Those are integers, right? I didn't put a dot. So Python is interpreting those numbers as integers. Thereby, when it got new numbers, it's saying, I'm a list or I'm an array of integers. So if you're going to give me something that's not an integer, I'm going to convert you to an integer before I do anything with you. So we were able to insert pies into this list, but because the list was originally comprised of integers, it turned them to integers. And this is important, right? I didn't even know this until I was sort of working with arrays yesterday. So this may be a source of frustration. This would be a hard error to track down. Okay, how do we fix it? Well, if instead I put these dots, right? And then I say, change the fourth position, change the first position, the thing at index 0 to 4, right? Now it puts in the 4. Okay, so the two takeaways are this. Given an array, you can actually reach into it and change it, like change individual elements, which is something that we often do. The second thing that I have to know is that these arrays can only hold one type. If they can either hold all integers or all floats or all whatever data type that you want. And whatever goes in first is the thing that sets the stage. Now, if you put a single float in when you create it, then it will just change everything else to a float. But if you ever see that you're printing your arrays and stuff is missing, ask yourself, did this automatically do some type of conversion? Is that why I'm missing data? You may sometimes want to add like an extra element to the back, right? You may want to sort of keep a list of stuff and accumulate on that list. So here's how you can accumulate. You have this function called append, and I can say to the array x's append 4. So that will do that. But if I look at x's here, the 4 is not there. Why not? Well, this function gives you a new list. It doesn't actually like mutate this list. So if I actually really do want to update x's, then I can say something like this. My x's is now going to be the old x's with 4.0 appended to it. You're used to, we just did increments and accumulation. You should be very used to statements like this, right? X's is equal to x's acted upon. And then you'll see that if we print x's, we'll get that. So is that clear, right? You can have a list and you can add stuff to the end of the list if you want. When would you have to do this instead of just changing it in the original list? Well, the original list here only has 3 elements. What happens if you want to add a 4th element? Right, like I can think of you want to, okay, so let's do I have something like this? That's a little bit different. Okay, so let's try this. Let's write store the first 100 primes. That's too many. Store the first 50 prime numbers in a list. Okay, so here's one way of doing it. I can start with an array, and that can be empty. And then I can have my counter. So we're going to count. Okay. K starts from 0. I want to count to 50. So while K is less than 50, let's increment K. So this loop is going to execute 50 times at this point. So then what do I want to do? I want to, oh no, this is going to be much harder. No, I think I'm doing something that is store the first 50 squares. I think will be a little bit more in our reach. Okay, so into this x's, I'm going to say append to x's the square of K. And let's just inside the loop print this x's. Maybe 50 is too much. We'll do 10. And let's see what happens here. Oh, I should have done that. Whoops. What is happening? Okay. See what's happening here? This is a very good illustration of like how the loop is working. So like this is the first iteration. So it x's starts empty. And then by the time we get to line 12, to x's, we've appended 1 squared. That's what is in here. Then we go back here, right? 1 is less than 10. 1 becomes 2. X's gets appended with 4. That's how you get that. Right? 2 is less than 10. 2 becomes 3. Append to the end of X is 9. Right? So there you have an example of when you may want to append something. Now, you can do this differently. I could have instead said, okay, just create me an array, give me 50 zeros. And instead of doing appending, I'm just going to say X is at K. Gets K squared, print X is at K. And we're going to see the exact same behavior, or we should see the exact same. Whoa, oh, they're floats now. So this is a little bit less. Okay. Yeah. So we're not going to see precisely the same thing because this was building a list and this is going into a list that's already, I shouldn't have put 50. That's 10. Yeah. Why did I put 50? Let's try that again. That's better. Okay. So here is my list of original zeros. And you can see I've already screwed up. Look, I put this thing here. I skipped I guess 0 should be the first square, but still I'm off by an index. So I really should move this to here. All right. So see, even I can screw this though. You got to be really careful with your edges. Okay. So here's the zeros list, right? This is, it replaced the 0th position with 0 squared. Then it replaced the first position with 1 squared, then the second position with 2, the third position with 3, so on and so forth. Right? So that's 2 ways of doing the exact same thing. One, just by adding to the end of the list, the other creating the list first and then putting it in. So the advantage of the first thing is that you don't need to know ahead of time how many spaces that you need, right? To do it like this, someone needs to tell you, like, you're going to have to hold 10 objects. So go ahead and create some space for 10 objects. Whereas the first way was you're going to have to hold an undisclosed amount of objects. So that's when you're going to have to use the append. Write some code that stores the first 100 Fibonacci numbers in an array. So we're going to have to do 2 things here, like read from the array and write from it. So this is going to be fun. So let's try to write some code that prints out the first 100 Fibonacci numbers. Print first 100 Fibonacci numbers. Okay. So how can we do this? So if we want the first 100 numbers, I'm going to do something a little bit different. I'm going to say, fill this array with 1s, right? What are the first 2 Fibonacci numbers? Right? 1 and 1. Right, so I'm going to fill the whole array with 1s. And now I'm going to do this. While K is less than 100, I want to say X is at K is equal to X is at K minus 1 plus X is at K minus 2. Remember, are the Fibonacci numbers? Every number is the sum of the previous 2 numbers. Okay, so this is what I want to show you. We have to modify the design pattern a tiny bit. Right? You may be tempted to say K is equal to 0 here, but you'd be wrong. And it's worse than that. You'd be wrong in a way which wouldn't throw an error, right? Because it would say you would do X is at 0 is equal to X is at minus 1 plus X is at minus 2. Right? You're sort of going to the end of the list. What is this? Where should I start? So I have a list of 100 ones, and I want to start doing the Fibonacci numbers. So the 0th position should be a 1, which it is. The first position should be a 1, which it is. And the second position, or the position at index 2, has to be the sum of the previous 2. So what should K be? What is the first thing here that should be set? Yes, 2. Good job. Okay, so let's see if this works. I'm going to have to print X's. Where's my mistake? What did I do wrong? I forgot to increment. Should I increment before or after? After, yes, because the first thing I want to do is check 2. Alternatively, I could have changed that to a 1, but let's just stick with your way. K is equal to K plus 1. Okay, let's try that again. If I could only hit the correct buttons. Oops. Okay, so these, you have to remember that these are storing floats. So it's going to look a little bit messy, but indeed, this is 1. This is 1. This is 2. This is 3, 5, 8, 13, 21, 34. It's just all sort of printed in scientific notation. So this sort of encapsulates the essence of like what working order arrays are going to be like. You often want to like read from arrays and use those and store something else. So is there any questions regarding this sort of piece of code? Since they are all integers, can we convert it to integers so it looks better printed? No, well, this is the thing that's screwing up, right? Because I can't tell ones that I want ones of integers. Now I could do something like this. Array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 20, 30, 40, 50, 60, 70, 80, 90, 100. And what has happened here? I don't even know what that's doing. Very bizarre behavior. Oh, no. Oh, I see. Oh, it's just trying to, yeah, it's trying to organize them all into columns. And this is overflow, so don't worry about that. Yeah, these are integers, right? So 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, right? But I put those integers there. As soon as I put ones, right, then it's going to put 100 floats. And to be honest, this class should, like, you use floats. You don't use integers, right? Integers are really only for counting in your world, right? Because when you do scientific computing, it's all going to be float. You're going to be doing a ton of number crunching, right? So integers to you guys are just numbers that represent counting things or incrementing indexes. So once I've used ones, I'm not sure that I can convert it to integers. Well, I can, but not with the tool set that you've been given. Like there may actually be like a command or an optional argument here, but let's not get into it. We really don't need that extra. Can you explain again why K is 2, right? Well, so how does X's look? X's looks like this. It's this, at the moment, it's like this 100 times. So Baptiste, do you understand that? Right, so just say yes every time that I've said something that, yes, okay. So this is the 0th position, 1st position, 2nd position, 3rd position, 4th position, 5th position, 6th position, 7th position. Do you understand that? Yes. Now I want to instruct the computer to say, I want you to go into the sequence, and every number, besides the first 2, should be the sum of the 2 numbers previous. So I don't look at this one. I don't look at this one. I do look at this one, and I change it to the sum of these 2. What position is this at? Matisse? It's right there. It is position. Second, let's just say it's at position 2. So you don't get confused. But sure, it's at position 2, right? Index 2. Right? Just so we can use the standard logic. Okay, so you understand that this is at index 2, right? Therefore, I should start processing this list at 2 onward. I need to skip the 0th position and the 1st position because those are already correct. So that's why I had to start at 2, right? Because I want to start processing the list from here onwards. Right? Because there are no 2 numbers before this, and there are no 2 numbers before this. Is sort of the base case. Does that make any sense? Great. So there are the answers. So in summary, you can now have a name, and that name can refer to like a sequence of data. So you used to have names that refer to one value, one number. Now you have names that can refer to like a collection of numbers. And that collection is ordered, and it's ordered from 0, 1, 2, 3, 4 to the length of that array minus 1. And that's all really you need to be able to understand from today. Like, you're going to need to practice, and you're certainly going to you're going to have to struggle a bit with walking out of bounds and getting your indexes right. Index arithmetic is always a pain in the ass, right? This is why linear algebra sort of gets a little bit hectic. This is why tensors are so hard to work with, right? But you just have to be sort of, again, more precise than you've ever been in your whole life, right? But don't give up, right? You just tell yourself, okay, I have to be very careful to stay in bounds. I have to be very careful to count from 0, and I have to be very careful about where I'm incrementing, right? Because that may actually cause errors. Now, I'm going to stop any questions. So ask me some questions, and then I'll stop the recording, and then I'll ask for questions again, right? Because it seems to be the case that there are people who want to stick around for maybe 15 and a half hour, which I'm totally fine with. So any questions regarding the material from today? Take your silence to mean no. Okay. And then also in general, I want you to start writing down things that confuse you about programming and Python in general. Like, have questions ready to go by the time we start using this hour to practice, right? You can't just I'll be done instructing, right? At that point, there is going to have to be some type of dialogue that happens. Okay. Yeah. Thanks, guys. Thanks. Enjoy your weekend. It's going to be really nice. I'm going to stick around for a bit though. So I'm just going to stop this recording